Hello and welcome to another edition of Sparky Help. This time we're going to look at initial verification and more specifically this schedule of inspections. For obvious reasons this is quite a long one, so I'll be broken up into parts as you can see below. So please like, share and subscribe to help me make these videos in the future. Many thanks. So let's continue with basic protection on the next bit. Basic protection. So basic protection, as it says there, presence and adequacy of measures to provide basic. So what it used to be called, which was much better, it was called direct contact. So basically what you're trying to do is prevent someone coming into contact with a live part. How do we do that? There are two main ways that we tend to do it, and those are the two that are listed here: insulation of live parts and barriers and enclosures. Typically domestic, that's what you can have. You can have them everywhere. Obviously it's probably the main ones you'll come across. But there are others, there are a couple of others that you've got: placing out of reach and obstacles that could also be used, but they can't be used in domestic premises. So installation of conductors, but what we're checking for is within your installation, is all the installation intact and can you touch any live parts whatsoever? If you can't, then it will be a tick. Obviously, if you've done something wrong, if you could. Barriers and enclosures is about IP ratings. So here we've got the insulation. This is all the regulation. Says basic insulation of live parts shall be completely covered with insulation which can be only be removed by destruction. Bear in mind, most of the time the manufacturers put this on for us, so we don't have to worry about it. What it does say there's a note, not that anyone would, I wouldn't have thought, live parts you can't use paint, varnish or lacquer to insulate. Don't know why anyone would do that. So that's going to get a tick. Barriers and enclosures are the main ones that apply, because remember we're trying to stop someone physically touching something. There are two sets of IP ratings ultimately that we apply, and barriers and enclosures are intended to prevent contact with live parts. So live parts shall be inside enclosures or behind barriers, providing at least a degree of protection of IPXXB or IP2X. What is that? That's roughly the size of your little finger. So we shouldn't be able to get your little finger inside an enclosure. If accessible, the horizontal top surface of a barrier enclosure shall provide a degree of protection of IPXXD or IP4X. What is that? That is a 1 mil diameter of piece of wire, effectively. That's what they test it for. So that's what we're effectively looking at when we do that. So we shouldn't be able to get it. So the front, sides, back, if it's accessible, and the bottom of an enclosure mustn't be able to get your finger in, which is IP2X, and the top is IP4X. Why higher on the top? Well, gravity will make things settle on the top. So if you was in a dusty environment or over time, if your holes were too big, eventually it would fill up. Additional protection. To do additional protection, this is where we tend to put RCDs because our regs drive us to do this. So this is for this reason, not the previous one. The use of an RCD is not exceeding 30 milliamp is recognised in AC systems as additional protection in event of failure of the provision of basic protection and any provision for fault protection or carelessness by user. So where have we done it? Have we put one in? Probably. So if we look at this first one, it says RCDs not exceeding 30 milliamp as shown by 415.1 part 7, and it says see items 8.14 of this schedule. That's on the back of the page ultimately, and let's have a quick look at what that is. It says if you're going to put an RCD in and those previous regulations, the 415.1 and anything within part 7, which is special locations where it says it's advisable to put one in, or you should put one in. This just breaks it down. So if you're going to put one in, what have you put it in for? Is it for sockets that are 32 amp or less? Is it for mobile equipment? Is it because your cables are concealed in the walls? Is it because your cables are in walls that have metal partition? Or is it the final circuit supplying luminaires within domestic household premises? If you've got any of those, it'll be a tick on this page, but when you get to 8.14, you'll tick and narrow down exactly where your RCD is actually protecting. So the chances are that is going to be a tick. Supplementary bonding, often known as cross bonding, where you might go across the hot and cold and the flow and return and all of those bits and pieces, and typically the sizes you're looking at for these is minimum of 4 mil unprotected. If you decided to put it in conduit, then it would be a 2.5 that you would put that in. So if you've got supplementary bonding as identified by 415.2 and part 7, then it would become a tick. And what does that basically say there? Additional protection, supplementary protective equipotential bonding, and we've got some notes, and it says note 1, supplementary protective equipotential bonding is considered an addition to fault protection. So it's an enhancement, which is what additional protection is. Note 3, supplementary protective bonding may involve the entire installation or a part of an installation or an item of equipment. And it also says additional requirements may be necessary for special locations, hence it does say part 7. So you might go on to agricultural areas and it may say put in extra bonding for, let's say, a cattle grid or something like that might be required. If you've got that, then you would have put it in. In domestic installation, the bit that would apply to us would be bathrooms, where it might say ensure that everything is earthed. However, if you put an RCD in there, then you don't need to do it. So probably will be an NA a lot of the time, because you don't need to do it if you're putting RCDs in, which what you'll do anyway. Then we've got other methods of protection, and it breaks it down to SCLV. So SCLV, if you've got alternative supplies. So what does SCLV stand for? It stands for separated extra low voltage. So this is below 50 volts AC as an output voltage or below 120 volts DC. So as you can see, this is for LED power supplies. A lot of these will be integral within the fittings themselves, but if you put in extra external drivers in, then this would be the case. If you're fitting these, then it will be a tick. What does it effectively do? Well, we're separating from earth. Okay, some people call it safety, but it's separated extra low voltage. So the idea is that obviously on the supply side, the transformer is earthed at the star point. So if we touch the line conductor on anything on the supply side, we'll get an electric shock, as probably you've experienced. But if on the output side of an SCLV transformer, not only have we reduced the voltage to a much safer level, i.e. below 120 or below 50 volts AC, but if you did touch the live conductor, there is no connection to earth anymore. So you could be grabbing hold of a metal pipe, grab hold of one of the line conductors, the positive conductor, and nothing would happen. The only way you can get a shock off of it, and it wouldn't be much anyway, but don't go trying it, is touch both conductors. So if you've got any of these fitted within an installation and you've got circuitry associated with it, it will become a tick. If you haven't got any, it becomes an NA. The next one is PLV. That's a similar type, but again you'd have to check to see what you've got installed. But PLV is a similar type of transformer. It's extra low voltage, but it's protective extra low voltage, but this time it is tied down to earth and therefore potentially could get shocked. So things will be unearthed as they go on the output side, but you'd need to check to see what type of transformer you have and have a look, see if we've got it, but the chances are it's probably going to be an NA. Next, we've got double or reinforced insulation, class 2 or equivalent equipment and associated circuits. So this is the middle symbol. So class 1 equipment would have the earth symbol on, because class 1 equipment has to be earthed. Class 2 tends to not be earthed. Class 3 is going extra low voltage and doesn't have an earth on the output anyway. But we're looking at the middle one. So if you've got equipment that has got the square within a square as equipment, you'll be putting a tick in. So the chances are you may well have installed some equipment that would be class 2. But it could also be part of an installation, hence it refers back to section 412 of the regulations. Electrical separation for one item of equipment, e.g. a shaver supply unit. Well, we don't need to, I'll put it up anyway, but this is a shaver socket. Shaver socket, it's not SCLV. Sometimes people think they are an SCLV, but it's not, because if you look, the output voltage is 230 volts and 115 volts. So actually it's a low voltage output, but it is separate. Okay, it is a separated supply, so it's similar to the SCLV, but it's not the extra low part, it's just separate from earth. So on these, hence they're allowed in bathrooms within the prescribed zones, obviously. If you was to have small enough finger and touch the line conductor in the 230 volt one, and even touch the sink, which is metal or whatever it happens to be, you would not receive an electric shock. The only way you can receive an electric shock off of this one, on the secondary side of the transformer at least, is stick both fingers into the socket there. Okay, so if you've got one of these, you may well have done, then it's going to become a tick. So that's effectively what the transformer looks like. Not to be confused with, they do shaver sockets that are single devices, so not a double module like this, but they don't have transformers on. Okay, so be very wary if you ever do come across them and they are just single modules, because they wouldn't be allowed in a bathroom because they are just direct connection. Probably going to have one, tick. The next one, we're looking at consumer units and distribution boards, adequacy of access and workspace for items of electrical equipment including switchgear. The regulations basically just says that wherever you put something you must have sufficient space for the initial installation and later replacement of individual items of electrical equipment, accessibility for operation, inspection, testing, fault detection, maintenance and repair. There are no measurements, you've just got to meet that. So you use your judgment. Have you still got it, or has someone built a wall in front of it? Wasn't there originally. So hopefully that would be a tick. Components are suitable according to assembly manufacturer's instructions or literature. Well, that's quite a big one. It is. That's a huge amount of writing. But if we just look at this, the general gist of all of this is that all the equipment you put in must be suitable as per the manufacturer's instructions. So what do we mean by that? Well, in a distribution board, what we mustn't start doing is putting a hodgepodge of different makes of circuit breakers and make them fit in the distribution board by bending the bus bar, filing a bit out of the lid to make it all go back on again. We're not allowed to do that. Anything that goes in must be confirmed that the manufacturer accepts it to be in that board. So it's just basically trying to keep everything the same and not mix and match between different makes and models. So hopefully that would be a tick. Presence of a linked main switch. Well, what are we talking about there? Well, that, as we'll tick it because it will be there, this is your main switch in your consumer unit. Depending on your earthing system and whether it's single phase or three phase will determine whether it's 2-pole, 3-pole or 4-pole. So you'd need to go and look at 462.2. But all domestic installations, single phase, and all single phase in general, you would make double pole, but it's more about who's able to switch it, why it is. So it's double pole in all cases. We don't have to think about it because the manufacturers tend to put a double pole switch in. When you go by 3-phase boards, it's the main switch you'd normally have to specify, because you want the current rating, but you might want a 4-pole or you might want a 3-pole depending what happens to be, so that might not be so standard when you order that. Isolators for every circuit or group of circuits and all items of equipment. Hopefully that would be a tick. So can we isolate things, and circuit breakers can be used as isolators? Can we isolate pieces of equipment within your installation safely within the consumer unit and distribution boards? Yes, we would have done. Suitability of enclosures for IP and fire ratings. So the distribution board, if you put your distribution board outside, it needs to be rated for outside or in an enclosure that is suitable for outside. If it's not, then it will be incorrect. Fire ratings, obviously making sure that it is metal and things like that. So here's the IP ratings that we tend to go by, and manufacturers make things too, so they might generically classify something IP 54. First letters is just ingress protection. The first number is all about solids, the second number is about water. So if we take the IP2X we had earlier, why do they say that? Well, they're only interested in the solids, and if you look at 2, it says a finger, which is 12.5mm in diameter, not length, because that would be a fairly stubby little finger, wouldn't it? They put an X in because they're not interested in the water part. Obviously manufacturers, when they test their equipment, they will give it both ratings because they don't know where you're going to use it, so they just give it a rating. It allows you to make the decision. As we've said, distribution boards are metal and shouldn't be able to burn down effectively. So there's the regulations that go with that particular one there. Hopefully a tick. Let's go over the page. The consumer unit's distribution board. Protection against mechanical damage where cables enter equipment. So does exactly what it says on the tin. Mechanical damage is physically something hitting your cables. So if cables are entering in your distribution board, are they protected for the environment of which they were in? So what are we looking at here? It says a wiring system shall be selected and erected to avoid, during installation, use or maintenance, damage to the sheath or insulation of cables and their terminations. The use of any lubricants that can have a detrimental effect on the cable or wiring system are not permitted. Every cable or conductor shall be supported in such a way it is not exposed to undue mechanical strain, and so that there is no appreciable mechanical strain on the terminations of the conductors, account being taken of mechanical strain imposed by the supported weight of the conductor itself. So basically, a terminal must not hold a cable in place, which for years effectively that's what we've been doing. Consumer units, it's the terminals that hold the cable there, and we've all been guilty, and there's many of them. The photos I just shown you, terminations holding them. The regulations haven't changed in that sense. What they've just added that is that note there that said that tails must be clipped. And as I think I've said before, within the on-site guide they show a drawing of a meter and a distribution board and some tails, and they say this is what a clipped cable looks like, and they've drawn some clips on the cables. What some manufacturers have done is they've put in clamps effectively above the main switch which can support and clamp the cable within the distribution board. Not all have done it, but some have, and I think that's quite a good idea. Helps support it. So that includes your tails. Have they been clipped, cleated, whatever you've done, supported in some way? Cable supports and enclosures shall not have sharp edges liable to damage the wiring system. Obviously the whole point of this is an enclosure is to protect the cables, not damage them. So if we've fundamentally failed at that, we've done something wrong. So that one should be a tick. Confirmation that all conductor connections are correctly located in terminals and are tight and secure. Well, I think we're fairly obvious what that one would be, but you'd be looking for something like this. Hopefully what you can see there is that the line and neutral are round the wrong way. This is on the main switch, so therefore the polarity would be wrong. So it's just a visual thing, that's all we're doing. So this is, we're going to have a look, going to pull it, touch it. Obviously we've probably installed it, so we'd probably know. Hopefully we wouldn't have installed it like this though. Hopefully if we recorrected that now, we would put a tick against it. Avoidance of heating effects where cables enter ferromagnetic enclosure, i.e. a steel enclosure. So what is that? That's single core cables passing through a gland plate. So this would have been incorrect. However, what they have done here is they have put a slot in between the holes, and that will overcome this problem of eddy currents in the gland plate. As long as we did that, that's fine. If they hadn't have put the slot in, and it's recommended about a 3mm slot is what should go in between the holes, and they're not the straightest in the world, but hey, that's just a job that's been noted, then you'd need to correct it if someone has gone individually. And this goes for single phase or 3-phase or anything, okay? The only one that doesn't need to go through is the earth, but all the live conductors must all go through the same hole. Or you can change the gland plate to Paxlin, but then you just cut a slot anyway, or something non-magnetic. So hopefully that will be a tick, because all your conductors, your single conductors, have gone through the same enclosure, same hole. Selection and correct type and rating of circuit protected devices for overcurrent and fault protection. Have we got the right size? So if we look at this, there's a 32, a B32 and a B20. But if we look at the cables going out, both are, well in this case I know because they are 2.5s. Well, on the 20 amp at 2.5, perfectly acceptable. However, a 32 amp with a 2.5 cable going out, that is incorrect. So that would need correcting. It could be that the cable is correct and the breaker is wrong, or it's the cable that's wrong and the breaker is correct. But without further information, we're not 100% certain unless you did the job in the first place, or you have the specification. Remember, you would have all this, in theory, you've got all this information to hand. So that's the sort of thing you're looking out for. Hopefully it's going to be a tick. The next one, presence of appropriate charts, warning notices and others notices. Hopefully fairly self-explanatory. What does the regulations require? It says a legible diagram, chart or table or equivalent form of information shall be provided indicating in particular, and then it lists 4 different things down the side there. So type and composition of circuit, points of utilisation served, number and size of conductor, type of wiring, to name but a few. And this should be a durable copy of the schedule relating to the distribution board shall be provided within or adjacent to each distribution board. So each distribution board we ever go to, we should see this. Obviously that always happens. So if we haven't got that, then we'd be looking for it. If we have got it, it becomes a tick. Warning notice or method of isolation where live parts are not capable of being isolated by a single device. So if you've got somewhere that you can't meet that requirement, then at least you've got warning notices. So have we got there? Look, warning multiple supplies. Isolate all electrical supplies before carrying out work. Isolate the mains at and isolate the alternative supplies at. So you're looking for something like that to warn somebody that actually just turning this off doesn't mean that it is dead. If you haven't already got alternative supplies, then it's probably going to be an NA. If you have got alternative supplies, you'll probably put a tick there. Periodic inspection notice, does exactly what it says on the tin, whenever the next inspection will be. Remember, it is the designer who decides when on an initial verification when the next inspection will be carried out. RCD 6 monthly test, and also you can lump in with that arc fault detection 6 monthly test, because there are devices out there that are RCBO and also arc fault detection. They're still quite pricey, but they are out there, so you potentially got one test button to do both of those, but luckily they're both 6 months. So if you've got an RCD, which you probably have, it's going to have test 6 monthly, because it's not quarterly anymore. It hasn't been for quite a while now. So you'd be putting a tick. If you've got arc fault detection, obviously it would be a tick, but if you haven't, that will be an NA. Warning notice for non-standard mixed colours or of presence of other conductors. So if you've got two versions, so if you've got red and black and you have brown and blue within the installation, this should go at the original installation to make people aware that there are two versions within this installation. Let's assume it's relatively new and it's NA. Next one down, presence of labels to indicate the purpose of switchgear and protective devices. So have you labelled everything? So dishwasher, fridge, freezer, anything else. So you had your disboard labelled up. Is everything labelled up where you expect it to be? Tick. Well, that's the end of this part, so please click on the next link and go to the next part to continue watching. Thank you very much.